TUNL, the Triangle University's nuclear laboratory, was founded in 1965 as a three-university consortium, and the original members are Duke University, NC State, and UNC Chapel Hill. And the idea was very simple, and that is that by pooling talents and resources, you could do more than any of the groups could do separately. TUNL today is a Department of Energy Center of Excellence, and we've added a fourth member, NC Central University. And that's allowed us to do research in all of the key areas of nuclear physics. Right here at the lab, we have 3 accelerator facilities. We have the high-intensity gamma source, or Higgs, which produces gamma-ray beams. We have the Laboratory for Experimental Nuclear Astrophysics, where we measure stellar reaction rates. And we also have one of the original TUNL accelerators, the tandem Van de Graaff, which is still an important part of our program and important nationally.
The high-intensity gamma-ray source, or Higgs, produces gamma rays by a process called Compton scattering. What makes Higgs unique compared to other Compton gamma ray sources is that the scattering process occurs inside the optical cavity of a free electron laser that is based on a storage ring. The collision between the electron and the UV photon produces a high-energy photon that we generically refer to as a gamma ray, though it does not come from the nucleus. We refer to it as a gamma ray primarily because it has the energy range that is appropriate for probing nuclear systems.
Here at TUNL, I perform experimental nuclear astrophysics research. My group, more specifically, is performing particle transfer reactions. So rather than measuring the reaction that may be occurring in a star, we measure what could be called an indirect reaction that measures the same nuclear physics properties that we're interested in. By being able to collaborate between different universities, we're able to perform the kinds of research that we wouldn't be able to do as a single institution. We can use facilities that a single institution wouldn't be able to maintain. As a result of that, the research output that we have as a group is at the forefront of the field.
I am part of the Experimental Neutrino Physics group here at TUNL. The Experimental Neutrino Physics group uses nuclear physics processes to study the fundamental properties of neutrinos and uses neutrino interactions to study the properties of nuclei. By having the 4 universities here collaborating at TUNL, we can build a real center of effort to lead some large-scale neutrino physics projects. TUNL collaborators played a major leadership role in construction of the Majorana demonstrator, an experiment looking for neutrinoless double beta decay in a former gold mine in South Dakota. We also have a very strong association with Oak Ridge National Laboratory. Recently, a TUNL-led effort in coordination with Oak Ridge's physics division used the spallation neutron source at Oak Ridge as a source of neutrinos to measure a neutrino-nuclear interaction predicted by the standard model that had never been observed before.
Well, our graduate students are really our major contribution to society, and we educate about 8% of all of the PhDs in experimental nuclear physics in the US, and they go on to a variety of careers.
Because of the nature of our accelerator facilities, in particular the smaller ones like the tandem accelerator and LENA, and to some extent Higgs, students get to think about optimizing experiments not just in the target room area or in the experimental halls, but also how to tune and optimize the accelerator and the beam parameters to the experiment.
We run, especially at the Tandem Lab, we run 24/7, and at the LENA Lab, we run 24/7. You cannot run by yourself. You can't run these experiments by yourself. You need to work in a team. And the graduate students bring in other graduate students. It could be the graduate students from their advisors group, or they could bring in a graduate student and say, hey, you have expertise in working this part of the accelerator. We're going to use that. Hey, why don't you come join our project? And so Teamwork is very important, and management. In addition, at the Lino Lab and the Tandem Lab, the students are also, they're setting up the beam. And so you have to know how to do this. And you're not going to learn right away. You learn from the senior graduate students, you learn from the postdocs. And so you build a teamwork, you build a responsibility, and you gain all of this experience.
Some of my best experiences here at Tunnel have involved big projects that a lot of us have worked on together, bigger scale problems than one person can tackle by themselves. And when it finally comes together, and even just the experience of working with people from different backgrounds and different knowledge sets has been really satisfying. We have more facilities than a single university would be able to maintain or afford. So we can do a wider variety of projects, we can do more ambitious projects, we can really push the envelope as far as what myself as a grad student would be able to do, or any other grad student.
Students that graduate from this facility really do have skills in many aspects of experimental physics. When they finished at Tunnel, and people would ask them, okay, well, what can you do? They would say, well, I come from Tunnel, I can do everything.
So for 50 years, Tunnel has succeeded by providing students with great educational opportunities and producing high-impact science at the same time. And these opportunities exist now, and they will exist for the next generation of students.